So this should be hopefully a fully comprehensive guide from absolute beginning to end of taking a web application, or in this case, an API specifically, a backend, from running it locally to deploying it to AWS and exposing that API publicly or internally, depending on your needs. So here, all I have is just a very basic API I created. This is just like a mock microservice for orders, kind of like customer orders for an e-commerce platform. The details of the application in this case don't matter at all. The point is, I'm assuming you have some type of backend and you want to deploy this backend for your front end to consume. Let me just choose the right config. Okay, there we go. So here I just have this running locally, and if I pull up Insomnia, I have a localhost endpoint here, and then I can make the request, and no staged order found for this customer. Great. The endpoint works. So this all works locally. The first step that we have to do is build a jar file. Well, specifically this is for Java, but I want to make it clear that everything we're doing is not language specific, although in this case I will be using Java and Spring Boot, but what you use, if you're using like C#.NET, it doesn't matter, or some other thing. Those don't matter. You'll have to change the details a little bit to kind of follow what I'm doing exactly, but regardless, everything should work fine. So all we need is a jar file, which is basically the executable that our API, where we can use to actually invoke our API, and this will be the application that's actually running on the server continuously. So here I'm using Gradle. I should have used Maven, because Maven, I feel like it's a lot easier than Gradle, but after a lot of pain and suffering, I managed to get it to work. So if you are also using Gradle, and if you're not, you can skip to the next time segment section. I should have everything sectioned out. But if you are using Gradle, then use this apply plugin and specify your main class name, and then add this jar with the manifest, where this will create the manifest file, and just specify your main class. And then I also added this tasks here, and I'll probably put this in the description, because without this, I'm getting a Gradle build error where it's complaining about duplicate manifest files, even though I don't have any. And then I'm not sure if this is actually required, but I added it just in case, because it was one of the things I found when I was trying to research all of the problems I was having with building. But if you have your build set up, then all you'll need to do is a Gradle W for the wrapper, Gradle wrapper build. And this should package all of your dependencies and such, and package everything into a jar file. So if the build succeeds, inside of your build folder, you should have this order service snapshot.jar. Although we're not actually explicitly going to do anything with it, we're just going to make sure it works with Gradle W run, which will basically run that jar file. And here you can see that it starts up. So that's the first step, is just getting a build working and running that build to make sure that when we actually want to deploy this, we can actually execute the application, because if we can't, that's kind of a problem. So now this is where we will switch over to AWS. And if you don't have an account already, you can create one. Everything I'm going to be using will be in the AWS free tier, so at least this example that we do will not cost any money. Although the free tier is very garbage, so I would only ever use it for testing, and I wouldn't actually use it to host your application, because even going through the setup, my EC2 instance crashed twice. And we might run into that here as well. So to actually host the server, we're going to create an EC2 instance. You can also search it here. This is basically just a virtual server that we can set up. So we're going to go to instances and launch instances. And then here's where you can name your server. So I'm creating an order service, so I'll just call this order service. And if you wanted to have like separate environments, you could create like an order service dev and order service prod or staging or whatever. But for now, just to like get the example working and show you how to get everything set up, I'm just going to use order service. And I'm going to use Ubuntu. I'm going to use the free tier. And I'm going to use micro, which is also free tier. There might be some, actually that might be the only free tier one. And then I would create a new key pair. So I usually use ED255, but it doesn't really matter. I actually already have a key pair that I created when I was testing this, so I'm just going to delete that one real quick. So I'll call this order service KP. Okay, yeah, I'll do KP2 because I already created that one. And that just went to my downloads folder. You could just put that wherever. It doesn't really matter. I will show you how to use it in a second. So for the network, you want to do two things. So first, if you are the only developer, then set the SSH traffic to my IP. And otherwise, if you have like multiple developers, then it's a good idea to kind of create a security group, or later go into the security and change the list of IPs. But it's usually better to like create a specific group, and you can look up the IAM settings for that. I think going over that will take too much time because this will already be long enough as is. So for now, I'll just use your own IP. And then we also want a public IP address to access. If this is an externally exposed endpoint, if it's internal, so for example, if this were like real life, if I'm creating an order service, I would probably not check this, and everything, all of the traffic would be handled internally. But just to show you how to get things working and connect as like an end user from somewhere, we will allow all traffic from the internet. And there's still some settings we'll have to switch later, but for now, this is fine. So launch an instance with those settings. And then we can head over to our instance, and this will just take a couple minutes to set up. It usually doesn't take too long. But in the meantime, while that's setting up, go into your security, and my server runs on port 8080, and as you can see, this is only looking at port 80 and 22. This is for the SSH, and this is also where you can kind of edit what IP addresses or groups can access specific endpoints or specific ports. But if we edit these rules, I need to add a rule to accept traffic to 8080 because that's where my server is going to run, and I'm going to allow all traffic. And again, if this were a different server or an internal server, I would set up some type of security group that only allows like internal traffic. But for this example, I'm just going to expose it to the world externally. So now our EC2 should be set up by now. Let's go back to instances. Oh yeah, here's my old one that I terminated. I could probably delete this one. Okay, whatever. I don't know how to delete it. Doesn't matter. So if we go to the connection, you want to go to your SSH client. And if you're on Windows, like I am currently, you will have to do a little bit of setup first. So if you look up PowerShell SSH, there's this get started with OpenSSH for Windows, and I would follow this. This is what I followed. I just chose this PowerShell option, and it shows you some commands that you'll have to run to install and kind of get SSH working through PowerShell. And hopefully, if I remember, I'll also include this in the description as well, because you may not be able to connect without that. But if you do have that installed, then we can open PowerShell. And I downloaded my key file into my downloads. So I'll just go to my downloads folder, and then I will copy this. And now we have connected to our server. So this is my my server. It's a brand new Linux installation. So we can update all of the repositories. And then we'll need a couple of things. So we'll install Git, mainly to clone my repository. If you don't want to use Git, you can also do like SSH transfers from your local machine to your server, but for now I'll just, and honestly that's probably a better option, but just to make it a little bit easier, I'll just show how to install Git and clone the repository, build it. I would probably advise against building code on the server, especially front end, because front end is notoriously extremely large. But for my case, I have a really small application, so this doesn't really matter that much. So we'll use Git. My backend also uses Postgres as a database, so I'll need Postgres, which by default this will install Postgres 14, but you can specify a specific version if you wanted. I'm not sure if I will need Gradle separately or if it'll come with it, but I'll just include it here. And I'll use OpenJDK 17 runtime environment and the actual JDK. Okay, I need PostgreSQL. So I'll just give it a minute to download all of these. I'm not sure how long this will take, so I'll just pause it here. All right, so everything just installed. And before I forget, once again, my server is running, or will be running on port 8080, and we'll need to allow traffic to that. So on Linux, or probably any Unix-based system, we'll use UCF and allow port 8080. I got this command mixed up with something else. I meant UFW, not UCF. I'm not sure what I was thinking of. So UFW allow 8080 or whatever port your server is running on, and this will allow traffic to that port. So now what we need to do is get the repository, and before we can do that, we'll need to generate a key for GitHub. My repository is private, but I think SSH keys are always required now. So take that key and just go through the docs here. I don't know how many keys I've set up in my life. and now we can fetch the contents of this public key, 25519.pub, and just copy this string here. And then we'll have to go onto GitHub, go to your settings, and then go to your SSH keys, new SSH key, and I'll call this order service. And now we have that key added. So we can go to whatever your repository is. Here's my fake order service. And then I'll just clone this into the home directory. And here, let me make this a bit bigger if I can, maybe not. Okay, whatever. Oh, there we go. I guess I should have done that from the beginning. So now we can go into order service, and or actually we need to set up Postgres. So now the next few steps will be specific to setting up Postgres. So if you're using a different database service, then you'll have to figure out whatever steps you need to do. But for Postgres at least, so on Linux it's a little annoying. So if I tried connecting to Postgres, then you get this peer authentication message, and you have to modify a file in, I think it's etc. Postgres QL 14 main. So there's this pghba config file, and you'll have to sudo to modify this, so don't forget that. And if you go down to the bottom here, this first line, localOL, we'll just change this to trust any connection for any user connecting to this on this server. And we will have to restart the Postgres service. Now let's try connecting. All right, now we can connect. So my my service or my API needs a user called osroot with password, and I'll just make some dummy password, osroot, osroot pass, and then create database order service with owner osroot. So obviously these two things are only specific to me because this is the database and the user that I need. But once again, depending on what your API needs and like what databases and users or roles are required, this is just all the database setup to actually like get the API working. But that's pretty much all the setup there needed. So now that we got Postgres working and the user created, the database created, let's go to the actual order service, and I'm going to set the my password required. So I have my API takes an environment variable osroot pass for the OS root user. So I set that to osroot pass, and let's build this. And hopefully it works first try. Sometimes that never happens. And also, since I'm on a very poor system, this is like almost the bare minimum that AWS provides you with. And so sometimes these build times are absurdly long, but it shouldn't be too long. And also, this is where, when I was testing this earlier, this is where my instance crashed. It crashed when I tried building it the first time, so I'm hoping, fingers crossed, that that doesn't happen in this case. But it looks like it's working so far. I'm just going to pause it and wait for it to fully build. Okay, so I forgot to mention, I'm almost 2 minutes into the build, and now it's trying to run the tests. Sometimes this takes long, and sometimes it even fails, like last time. Oh, my time just froze, so I think my instance crashed. Yes, it did crash. I was going to say that we can use Gradle W build -x or -x test to exclude all of the tests. But now we'll be able to see what to do when your instance crashes, because this is pretty much one for one what happened last time. Whenever I tried building my source last time, my instance crashed. So in this case, you'll have to stop the instance and restart it basically. And also, I wouldn't recommend rebooting, because when I tried rebooting, it didn't actually do anything. So I just completely stop the instance and then wait for it to finish stopping and then restart it. The one downside to this is that every time you start your instance, you get a new public IP address. So right now, this is my public IP for this instance. But whenever we restart it again, this IP is going to change, and that will make it like virtually impossible to manage, because your endpoint, this is your DNS, at least if you use like the default provided ones. This is what you would be using to like make your endpoints, and if your IP changes, then this DNS changes, and then you're gonna have to update all of your endpoints, and that's really annoying. So I think what you can do is, if you set up an elastic IP address, I believe these are purely static, so regardless of if you restart your instance like 100 times, it doesn't matter. Like, you have a dedicated IP address for this instance. And if you're really going for like an actual production build, I would probably get an elastic IP address, or even like get your own domain and have your own IP address, and then you can basically point this instance to that. So those are probably two options that'll work. But obviously for this example, just like get things running and working and show you how to get everything set up, I think that's way overkill to show here. So I just felt like it was important to bring that point up. So I'm just going to wait a little bit for this to stop. It usually takes like 5 minutes or so. It takes a really long time, which is why it's always super annoying whenever this crashes. Oh, actually now it just stopped. So let's restart that instance. And then now this will be pending. And this will only take like a couple minutes. So I'll pause until that's ready. All right, so now our instance is running again. And I don't remember the last IP, but this IP is a little different than the last one. So now we can follow the same connection steps as last time. Copy this, go to our PowerShell, go to your key file, or you can provide the path to your key file, but this is more convenient, and just reconnect. All right, so the good thing is, even if your instance crashes, we didn't lose any progress. So here, I still have everything. So now we're going to build this again, except I forgot to exclude the test directory. So if you use this -x and test, you can avoid building all of the tests. So this should hopefully speed things up a little bit, but you know, usually this takes a little while, so I'm going to pause this until it's done. All right, so that finished building. It actually was a lot faster than I expected. So now, just to make sure that everything works, I'll need to re-export my OS root pass because I lost my environment variable after the restart. And let's just make sure this works. All right, so we started everything up, and remember that we exposed port 8080 earlier. So just to make sure that it's working, we can copy this public IP, and we can go to a port checker. So if you copy your public IP and check 8080, this is closed. Okay, interesting. Okay, well, it turns out that I'm just kind of stupid, and I was using the outdated IP address. So after copying and pasting the new one, this port is open. I'm just running a dummy server on with Python. So now if I actually run the new Java server, wait for this to load up, and let's go over and copy the new DNS, and let's paste that here. And now you can see that works. No staged order found for this customer. This is the AWS endpoint. However, so now that we verified it works, we are almost done. There's actually only one more step to do. Obviously, we don't want to run the server manually because that's kind of annoying, and you can also only run one thing at a time, so you wouldn't be able to run like a backend and a front end at the same time, for example. So we're going to use systemd, which is a pretty popular way to host services on Linux. So before we do anything, we're just going to create a simple run script, which basically will just copy ~w run, because whenever we create the service, we just need an entry point. And so the entry point will be this script, and just be sure to make it executable. So now we're going to go into etc systemd system, and this is where a bunch of services are. So be sure to sudo, and we will create an order service API.service. This name doesn't matter, that's just my name, but it does have to end in .service. And we will just we'll just copy a template, systemd service. See if this is a good template. Okay, that is not what I wanted. Example. Sure. So we will just take this, and we don't need all of the stuff. And also this, everything under description, so we don't need some of these things, but anything under the description put under service, otherwise it might not work. And this will just be order service example. We need to create a working directory, and this will be the home. Ubuntu is the default user, order service. So the reason why you have a working directory is because it gives context to our entry point script. So if we go to home, Ubuntu, order service, and we look at our run script here. So this is using the local directory, and we're just giving context that, you know, this directory that we're in, that we're executing things in, is under our home Ubuntu order service. So that's the point of that. And typically it's probably a good practice to create a user specific to running the service. That way, like, the root user is not running it. So you could create like you can create like an order service user, or, you know, like some service account thing that is dedicated to running the service. That's probably a good practice. But for the sake of time, I'm just going to make this Ubuntu, which is the default root user. Again, I would not recommend doing this if you're actually deploying this for real. I would spend the time to create a user specific to running the service. And then the exec start, this is the entry point. And so this is going to be, we're running a bash script. So this will be user bin bash, which I think you could do which bash, it'll give you that directory. So user bin bash here. And then we need to specify the full path to the script. So even though we specified this working directory, this does not apply to this exec start. So we still have to use like full paths. So home Ubuntu order service run.sh, or actually, now what we could do instead, I just thought of this. We could, I think, just invoke Gradle here. We'll just call Gradle w run. Because that Gradle is also in that local directory, so we actually don't even need that script. So these are pretty much the only settings that we'll need. So now if we go to system control order service API start, what did I name this? Order service API. Oh, I mixed the order. The start comes before. So now let's check the status. Okay, so now you can see that this is running. And so now, see, you can, I'm freely using the server while the API is actually running in the background. So if I bring this up again and send another request, okay, well, that's embarrassing. Oh, it's possible that the server actually didn't finish starting up yet, because that usually takes a minute. Okay, let me just double check on the status then. Oh, okay, this did fail. Oh, I need to specify the environment variable. So let me go back here. Because remember, at least for my case, I needed that environment variable that specifies the database password. So if we go to environment, you can specify your environment variables. So mine is just os root pass equals, and then I set it to os root pass. And then whenever we make changes, you'll have to use daemon reload. I think that's correct, yeah. And then we can start this service again. Sometimes this takes a minute. So I'll just pause it now. All right, so that finished running. We can check the status. So it looks like that's running. Let's check if we can access it now. All right, there we go. So now this is running. So now we have the server running in the background. So I have full control over the server. And even though I'm not manually running it, I can still send requests to the server. And then, you could do something very similar with the front end. So this, right now we're hosting the back end, but you can set up another service that hosts the front end. And then instead of like running the gradle run, you'd have like npm serve or whatever it is. I don't remember. I haven't done front end in a minute. The last thing is we can create, if we use enable, enable will set it to where whenever our server restarts, then it will automatically boot up that service again. So, if for whatever reason our server went down or we just manually restarted it, on startup, it'll begin that service again and then begin running our API. However, the one caveat in this case is unless you have a static IP set, it's going to be a little annoying because your endpoints are going to be out of date. So like right now, if we restarted the server, this endpoint is going to be old and it can't use it anymore. But yeah, I think that's pretty much all there is to it. So this was like a full start to finish, like starting from a development API into setting up the whole EC2, setting up the database, creating the service, running the service. And we did run into a couple of problems along the way, but we eventually resolved those. So hopefully you found that useful, and I'm sure there's probably some questions someone might have. So feel free to ask anything in the comments, but other than that, good luck.